In Unit 3, we talked about how to prove congruent triangles. So we had two methods for doing this. One of them was using rigid motions or a sequence of rigid motions, and then the other idea was using our Euclidean proof. So the first key idea is that two figures are congruent if and only if there exists a sequence of rigid motions that will map one figure onto the other. So for these examples on this page, we want to use transformations to be able to prove that the triangles are congruent. So the first thing is I'm starting with triangle ABC, and I need to prove that it's congruent to GHI. So that means I'm going to start with this triangle and try to map it onto triangle 2 using rigid motions. So what I like to do first is check the orientation, which means the order of the letters. So if you just follow this order, so A to B, B to C, and then back to A, and then do the same thing for this. So G, H, H to I, and then back to G. If you look at the direction of the arrows, they're the same direction. So that means that these have the same orientation. The order of the letters is the same. So whenever you have the same orientation, it means that we either had a translation that occurred or a rotation. So if you can't figure out how it mapped, this is kind of the strategy how to do it. If the orientation changed, then it would have been a reflection. So in this case, now I know that it was either translation or rotation, so I just have to ask myself, did this figure 1 turn to become figure 2, or did it just slide? And at this point, you can see that the positioning is the same, so it just slid to go from triangle 1 to triangle 2. So we have to figure out, so we know it was a translation based on the picture. We just have to figure out how it slid. So if you start at B, B would be getting matched to A, because see how B and H are both in the middle. So B gets mapped to H. So we would be moving 1, 2, 3. So we went right 3 and then down 1, 2, 3, 4, 5. Now you could do that from C to I. Those match up. They're the last letters there. So C to I was right 3, down 5. A to G, right 3, down 5. So it's the same translation. So that means we can say that triangle ABC is congruent to triangle GHI because a translation of right 3 and down 5 units maps triangle ABC onto triangle GHI. It's important to make sure you state the order here. So it's this triangle is mapping onto triangle number 2. So that means I started with triangle 1 and it moved to triangle 2. And then we need to mention that translations are rigid motions and since they are rigid motions, you could also say rigid transformations, either one. So translations are rigid motions which preserve side lengths and angle measures, which is what makes the figures congruent. So it's important to mention that the rigid motions are creating congruent side lengths and congruent angle measures, because that's what's making it congruent. So when you're doing these, you want to make sure that you state the specific transformations, so in this case translation, right 3 down 5, and then you need to mention that those are rigid motions which are preserving the side lengths and angle measures which make them congruent. If we were trying to prove similar, then we would be doing transformation or similarity transformations, preserving angles but changing sides to make them proportional. So it's important that you're saying that these are congruent because the sides and the angles are staying the same. So if we look at the second example, it's going to be the same idea. So using transformations prove that triangle ABC, so I'm going to start with triangle ABC and then TKH is what I'm going to map it onto. Now when you're doing this, keeping in mind that you could start with this triangle here and move to the red triangle, just make sure that you're consistent. So if I'm going to start with the red and go to the blue, then I need to make sure that that's how my transformations map. So I'm going to look at my orientation. So A to B, B to C, and then go over to the other one, T to K, K to H. So overall, look at the direction of the arrows, same direction, so same orientation. So same orientation means that this was either translation or rotation. So then you ask yourself, did the position change? Did it turn? So you can see that the figure turned because now the longest side's facing upward versus it was facing to the right. So we know that this has to be a rotation. So now we need to figure out how much did it turn. Well, it moved 1 quadrant. So since it moved 1 quadrant, that tells me 90 degrees. And then to figure out the center of rotation, you could connect any pre-image and image points. So like if I connected A and T, I could then do the perpendicular bisector of that and then connect, let's say, B and K, do the perpendicular bisector of that one. Where those cross, that's the center. But if you look at this point right here, you can kind of see that if I were to connect from A to that point and then T to that point, see how it looks like a right angle? And then if you look at from B and then K to that point, another right angle, and then same thing for C and H. So that's a good indication that the center is just going to be at the origin. So you can use that to say that the center is at the origin. My rotation is going to be in a counterclockwise position. So 90 degrees counterclockwise, and it's centered at 0, 0. So I just need to make sure I mention that. Now, if you can't find the center, though, then you'd have to do the perpendicular bisectors and see where those cross. So I can now say that the triangles are congruent because a rotation, and make sure you're being specific, so not just a rotation, but a rotation of 90 degrees counterclockwise centered at the origin will map basically triangle 1, so in this case triangle ABC, onto triangle 2, which is TKH. And then we need to mention that rotations, so rotations are rigid motions which preserve, so keeping congruent angles and congruent side lengths, which preserve side lengths and angle measures. So again, making sure that you're mentioning that the angles and the sides are staying the same, that's what's proving that these are congruent. So you're saying that they're rigid motions, which are creating congruent side lengths and congruent angle measures. You could write that, or preserve just means keeping them the same. And then you need to be specific about your rotation. So that would be a transformational proof that verifies that these two figures are congruent using rigid motions. The next idea that we talked about in this unit was using your 5 congruence theorem. So these are called Euclidean proofs. This is where you do your 2 column statements and reasons. So just a refresher, you have 5 theorems that work: side, 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 angle, side. Make sure the angle's between the 2 sides, so it's the included angle. Angle, side, angle, the side that's congruent touches the 2 congruent angles. Then we have angle, angle, side, or you could flip the order of that. And then HL, this is, we often write dash right triangle because it only works in right triangles. So HL dash right triangle. And then the 2 that don't work are your SSA, or the donkey theorem, spells a bad word backwards, so it doesn't work, or AAA, that's who you call when your car is broke, so that one also doesn't work. So using those, we also had several theorems, and make sure that when you're doing a proof, you always want to mark your diagram first, meaning whatever the givens are, you need to label in your diagram and mark them. If you see in the diagram, looking for vertical angles, so looking for the X shape, look for those shared sides. So these are very common. So as soon as you mark all your givens, you want to then look for your vertical angles and your reflexive property, anything that's shared. So shared angles and shared sides. If the triangles are overlapped, highlight them, separate them so that you can just look at single triangles instead of one big overlapped picture. And then you always want to look for shared sides when you have overlapped triangles, shared side and shared angles. And then the rest of these I'm just going to leave up to you. Some of this stuff we haven't talked about yet, like the circles, you don't need to worry about that for the midterm. Parallelograms, we haven't talked about that yet. But we have other reasons for segments, so midpoint, bisector. We have the addition postulates, reasons that involve angles, so perpendicular lines giving you right angles, vertical angles, bisector. So just read through these, make sure you know them, because these are like your banks of reasons that you can use to make conclusions. You have all these parallel lines and what they create. And then, so just again, reading through these, here's your 5 methods that prove congruent triangles. And then just remember CP/CTC. This is whenever you're trying to prove congruent parts. So congruent sides or congruent angles. And whenever you do this, you have 2 steps. You always have to prove that the triangles are congruent. And then you can say, well, then all of the corresponding parts are congruent. So that's what CP/CTC stands for. So it stands for corresponding parts of congruent triangles are congruent. So it's CP/CTC. So all of the corresponding parts of congruent triangles must be congruent. So that's the idea behind that. So let's look at 2, these are kind of shorter proofs, but just to kind of get you thinking again about proofs. So really, when you do proofs, the only way that you can really study for these is going to be just to know your reasons and do some practice ones. But no proofs are going to be the same. So you really have to know those previous 2 pages. You got to know how you can prove congruent sides, how you can prove congruent angles, all of those things. You can't make up reasons. It can only be what's given on those previous pages. So if we look at this, our givens, we can list those first. So I have my 2 columns. I'm going to write my givens. And then we're going to look at what are we trying to prove? Well, I'm trying to prove triangle ABC. So it's a good thing to highlight too, so you can see exactly what you're looking at. So triangle ABC, I'm trying to prove that that's congruent to DCB. So this triangle here. So I mark my givens. So I have AB and DC. I have AC and DB. And then from here, I always need a third piece of information. So look at the diagram, because these givens don't allow us to make any further conclusions. But if I look at the diagram, I have this shared side, so I can mark that. So BC is congruent to CB, and that's by the reflexive property. So it's shared. And then from there, I have enough information to say that the 2 triangles are congruent by side, 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 because I have all 3 sets of sides. So then the next one here, you're trying to prove congruent parts. So you're trying to prove 2 congruent sides. So this indicates that I first need to prove congruent triangles, and then use CP/CTC. So the triangles that those sides belong to, we need to prove are congruent. So let's look at what triangles they belong to. So EJ is this side right here. So that's going to belong to this green triangle. And then HJ is this side right here. That belongs to this blue triangle. It's a side in the blue triangle. So those are the 2 triangles that I need to prove are congruent. So let's go ahead and start our proof. We'll write our statements and our reasons. So write your givens. EF is congruent to HG. the next given says that they're parallel. So parallel does not imply congruent. You can have two lines that are parallel and not congruent to each other. So that's going to be something just to make note of. So in this case, we have EF and HG. And we also have that those are parallel. So it's just a coincidence that these happen to be parallel and congruent, but not always will that be the case. But in this case, we have parallel. So notice I put the little arrows on there. And as soon as I think parallel, I'm thinking about the Z shape. So if you look, you have a Z shape here. So that tells me that this angle and this angle are congruent. And then I also have a Z shape going the other way. So that would mean these two angles are congruent. So really, that'll give me enough information. So I know that angle, so if you want to put numbers in there, you can. I'm just going to use the single letters for these. So I can say angle F is congruent to angle G. And then angle H is congruent to angle E. And the reason for that is going to be because those lines were parallel, we have congruent alternate interior angles. So parallel lines imply congruent alternate interior angles, making sure that you say that they are congruent, because if the lines aren't parallel, there's still alternate interior angles, but what makes them congruent is the fact that the lines are parallel. So now we could say by angle side angle, the two triangles are congruent. You might be thinking too, could we use vertical angles here? We can. So right here we have vertical angles. I'm just not even going to mention them though because I already have enough information. So you could have done vertical angles and then one pair of these alternate interior angles, so either E and H and then or F and G, and then you would have had angle, angle, side. But I'm just going to use, this is the shorter way, so that's why I chose that way. So now I can say that the two triangles are congruent. So triangle FEJ is congruent to triangle GHJ. And that, for me, based on my proof, is going to be angle, side, angle, the sides between the two angles. And then the last thing is to prove that those two corresponding sides are congruent by CP/CTC. So EJ is congruent to HJ by CP/CTC. Your last statement for CP/CTC proof should always be that you're proving the congruent parts because of CP/CTC. The congruent triangle statement should only ever have one of those 5 reasons. I've seen people put congruent triangles with CP/CTC. That doesn't match up. CP/CTC is for congruent parts. Congruent triangles has to be one of the 5 theorems: side, 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 angle, 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 side, HL, or side, angle, side.